Hello, my little Sigmas. Today we're going on a freaky expedition of algebra where we'll explore some freaky expressions and equations, but more freaky.
Ate 5 homeless people because I thought they were watermelons.
1. Expanding expressions. I have 6a plus 12b. Imagine this like splitting a Skibidi Ohio pizza with a Sigma squad. You got 6 pepperoni slices, A, and 12 mushroom slices, B, all cooked by Baby Gronk and his Livy approved Rizark, and when you share it you're basically hitting the slices with a half goon multiplier, so half of 6a becomes 3a and half of the 12b becomes 6b, giving you a final expression of 3a plus 6b, certified Sigma Mathris. B, and plus 2n. 5. This is basically a secret Skibidi Ohio code we got and unlock, so we whip out the FOIL method like a Gita Sigma decoder. First is n times n giving n squared. Outer is n times minus 5 giving 5n. Inner is 2 times n giving 2n. And last is 2 times minus 5 giving minus 10. Then we mash all that together into n squared. 5n plus 2n. 10n combined like terms to get n squared. 3n, 10, which is peak Sigma algebra Riz no cap. C, a plus 2b squared. Squaring is basically making something fight its own twin. So, a plus 2b squared becomes a plus 2b a plus 2b, like a glitchy Ohio mirror battle. When we foil it like we are trying to unlock some Fortnite secret vault, a times it gives a squared, a times 2b drops 2ab, 2b times it gives another 2ab, but 2 NPCs walking into each other, and 2b times 2b becomes 4b squared because the B twins decided to go full final boss mode. Put all of it together and it turns into a squared plus 4ab plus 4b squared, cleaner than a fan edit with the newest goofy edits to beat Strand. B, 4x, y squared. Squaring just means something is throwing hands with its own cologne, so, 4x, y squared becomes 4x, y 4x, y? We hit it with FOIL because that's the secret move. First is 4x times 4x giving 16x squared. Outer is 4x times y giving 4z. Inner is y times 4x giving another 4z. Last is y times y giving y squared. Put it all together and it becomes 16x squared, az plus y squared. Real Sigma brain rot math energy. E, 2v, 1/3 w 3v plus 2/3 w. We foil this like we're speedrunning homework in Ohio. 4, 2v, 1/3 w 3v plus 2/3 w. First gives 2v times 3v, which drops 6v squared. Outer gives 2v times 2/3 w for 4/3 vw. Inner gives -1/3 w times 3v for vw. Last gives -1/3 w times 2/3 w for minus 29 w squared. Toss it all together and you get 6v squared plus 4/3 vw, 29w squared. Combine the vw parts and it settles into 6v squared plus 1/3 vw, 29w squared. Straight brain rot heat, cooked fresh in the Ohio kitchen. F, H, k squared minus 4 hours 2k minus 3 hours. First we expand h, k squared with FOIL and that gives h squared, 2hk plus k squared. Then we let minus 4 hours run through, 2k minus 3 hours, and it drops 8hk plus 12h squared. Now we just smash everything together, h squared, 2hk plus k squared, 8hk plus 12h squared. Combine the like terms and it settles into 13h squared, 10hk plus k squared. Real simple brain rot math cooking. 2. Factorizing expressions, a 12 meters to 18 square meters. To factor this, we first look for the GCF, and since 12 and 18 both get cooked by 6 and each term has an m attached, the GCF ends up being 6 meters. Once we pulled out that 6 meters, the leftovers are 2 from the 12 meters and minus 3 meters from the minus 18 square meters. So the whole thing settles into 6 meters 2 to 3 meters. Easy brain rot factoring. B, y squared, 81. This one's a classic difference of squares moment, since y squared, 81 fits the a squared, b squared pattern, and 81 is really just 9 squared hiding in plain sight. So once you spot that, it instantly breaks down into y plus 9y, 9. Easy brain rot move. C, 4ab, a squared b. The GCF in this expression is 4ab, so we yank that out first, and once it's factored the first term turns into 1 while the second turns into 2a because 80 squared b divided by 4ab drops right to that, leaving the final answer as 4ab 1 to 2a b, x squared, 16y squared. This one is another difference of squares moment, since x squared, 16y squared can be seen as x squared minus 4 years squared, and once you spot that it instantly cracks open into x plus 4 years x minus 4 years. S 3 squared, 1, think of S 3 squared as one chunk and 1 is the other chunk, and boom, it's another difference of squares moment, S 3 squared, 1 squared. Break it into S 3 plus 1s 3, 1, then simplify inside the brackets and you get S 2s 4 f x squared plus 4x plus 3, we're just hunting for two numbers that add up to 4 and multiply to 3, and the numbers that flex those stats are 3 and 1, so the factored form drops straight into x plus 3x plus 1, g, x squared plus 2x, 15, we're looking for two numbers that add up to 2 and multiply to minus 15, and the numbers that hit those stats are 5 and minus 3, so the factored form comes out as x plus 5x, 3, straight up brain rot energy. X squared plus 6x plus 8, we're on the hunt for two numbers that add up to 6 and multiply to 8, and the numbers that check both boxes are 4 and 2, so the factored form flexes as x plus 4x plus 2, pure brain rot math energy. 6cd, 2ce, 3bd plus b, this one's a bit spicy, so we group the terms like 6cd, 2ce, plus 3bd plus b, then factor out 2c from the first group and b from the second to get 2c 3d, e, b 3d, e, spot that, 3d, e, is common to both, so the whole thing collapses into 2c, b 3d, e, smooth brain rot factoring energy unlocked. 3. Simplifying expressions, a plus 2 slash 4v plus, a, b slash 2v to add these fractions, we need the least common multiple of 4v and 2v, which is 4v, multiply the second fraction by 2 halves so, a, b slash 2v, becomes, 2a, 2b slash 4v, now we can add them, a plus 2 slash 4v plus, 2a, 2b slash 4v, and when we combine everything, it simplifies to 3a, 2b plus 2 slash 4v, smooth brain rot fraction flex. B, 3 slash 5ab, 5d slash 4c, the least common multiple of 5ab and 4c is 20ab, so we multiply the first fraction by 4c slash 4c and the second by 5ab slash 5ab. That gives 12ce, 20ab, 25abd, 20ab, and when we combine them over the LCM, it simplifies straight to 12ce, 25abd, 20ab, smooth brain rot fraction flex. C, 4 slash f squared g, 3 slash 5fg, the least common multiple of f squared g and 5fg is 5f squared g, so we multiply the first fraction by 5 and the second by aff. That turns them into 20, 5f squared g, minus 3f, 5f squared g, and when we combine them over the LCM, it simplifies straight to 20 to 3f, 5f squared g, clean brain rot fraction flex. D, n plus 2 per square meter plus n, np to add these fractions, we find the least common multiple of square meter in np, which is m squared p. Multiply the first fraction by p being the second by mm. That turns them into np plus 2p, m squared p, plus nm, m squared p, and when we combine everything over the LCM, it simplifies straight to np plus 2p plus nm, m squared p, smooth brain rot fraction flex. E, 5x slash 8yz plus y, 1 slash 12xz, the least common multiple of 8yz and 12xz is 24z, so we multiply the first fraction by 3x slash 3x and the second by 2 years slash 2 years, that gives 15x squared, 24z, plus 2y squared minus 2 years, 24z, and when we combine everything over the LCM, it drops straight into 15x squared plus 2y squared minus 2 years, 24 is smooth brain rot fraction flex. F, RS / 4 years plus 2, R / 18yz. The least common multiple of 4 years and 18yz is 36yz, so we multiply the first fraction by 9z / 9z and the second by 2 halves. That turns them into 9RSZ, 36yz, plus 4 to 2r, 36yz, and when we combine everything over the LCM, it simplifies straight to 9RSZ, 2r plus 4, 36yz, smooth brain rot fraction flex.
Every day, I imagine a future where I can be with you.
Question 4, sharing chocolate. Think of it like grandma's chocolate bar is k squared, 16 cm long, and she's handing it out to k4 grandchildren. To see how much each kid gets, we divide the whole chocolate by the number of kids, so it becomes k squared, 16, divided by k4. Then we notice k squared, 16 is a difference of squares, turning into k plus 4k4. After that, the k4 cancels out like a goofy NPC disappearing, leaving us with k plus 4. So each grandchild ends up getting k plus 4 cm of chocolate. Easy little brain rot victory.
I got my own PC now.
Question 5. Part-time workers Gurdip and Jumarang are part-time workers in a grocery shop. They both work different hours and get paid different amounts per hour. We need to figure out how much each of them earns in total. Jumarang's pay, hourly pay. Jumarang is paid RMX per hour. This means that for every hour Jumarang works, they earn RMX. We don't know exactly how much this is, but we can use the letter X to represent the amount. Hours worked. Jumarang works 2x plus 3 hours. This means that Jumarang works for 2 times the amount of x plus 3 more hours. Total pay. To find Jumarang's total pay, we need to multiply the hourly pay by the number of hours worked. So, Jumarang's total pay is RMX times 2x plus 3. We can simplify this expression using the distributive property. RMX times 2x plus 3 equals RM2x squared plus 3x. This means that Jumarang's total pay is RM2x squared plus 3x. We can simplify this expression any further because we don't know the value of x. Gurdip's pay, hourly pay. Gurdip is paid RM3 less than twice Jumarang's pay. This means that Gurdip's hourly pay is 2 times RMX. RM3 equals RM2x, 3 hours worked. Gurdip works x plus 2 hours. This means that Gurdip works for the amount of x plus 2 more hours. Total pay. To find Gurdip's total pay, we need to multiply the hourly pay by the number of hours worked. So, Gurdip's total pay is RM2x, 3 times x plus 2. We can simplify this expression using the distributive property. RM2x, 3 times x plus 2 equals RM2x squared plus 4x, 3x, 6 equals RM2x squared plus x, 6. This means that Gurdip's total pay is RM2x squared plus x, 6. We can simplify this expression any further because we don't know the value of x. Therefore, Jumarang's total pay is RM2x squared plus 3x. Gurdip's total pay is RM2x squared plus x, 6. So that is all for the video. I will make a second part with questions 6 until 10 and after this I'ma doom scroll on TikTok while listening to top tier peak brain rot music.